Next would be chemical engineering. In a nutshell, the BSCHE program develops student skills in the analysis of chemical processes, the design of effective laboratory experiments to test hypotheses and verify assumptions, as well as to analyze and interpret data and simulate processes. Other components of this program are the processes of evaluation, planning and preparation of specifications and cost estimates, operation and management of industrial plants. They are not only limited in laboratories. Chemical engineers are more on large-scale processes of chemicals compared to chemists. Some of CHE responsibilities are the following. Determine the most effective arrangement of operations such as mixing, crushing, heat transfer, distillation, and drying. Direct activities of workers who operate or who are engaged in constructing and improving absorption, evaporation, or electromagnetic equipment. Or perform laboratory studies of steps in manufacture of new product and test proposed process in small-scale operation. Chemical engineering students may become chemical engineer who works in biotechnology, chemical process, design and construction, electronics, energy and fuels, and food industries, and is responsible for developing new industrial processes and designing new process plants or equipment or modifying existing ones. They may also want to become instrumentation engineer who designs strain gauges or sensors that capture data about the safety, efficiency, and reliability of industrial machines used in the manufacturing process. Or they may want to become materials engineer who is responsible for the research, specification, design, and development of materials to advanced technologies of many kinds. Their expertise lies in understanding the properties and behaviors of different substances from raw materials to finished products. Next would be electrical engineering. In a nutshell, BSEE program centers on the generation and utilization of electricity from industrial, commercial, and residential purposes. Apart from the production of electricity, BS in Electrical Engineering also deals with the development and real-life applications of electrical circuitry, digital systems, electrical equipment, and machine control. Electrical students may want to become electrical field service engineer who troubleshoots and repairs a full line of electrical equipment, performs maintenance routines, and determine if there are electrical discrepancies. Or they may want to become electrical design draftsman who creates layout and wiring diagrams that are used by installers in setting up electrical systems and equipment. Or they may also want to become project engineer, who involves the usual technical engineering tasks like design, development, implementation, and maintenance of electrical systems and equipment, and project management duties such as the preparation of work schedules, leading the subordinate technical works, and management of resources. Next would be electronics engineering. In a nutshell, electronics engineering focuses on the conceptualization, design, and development of electronic, computer, and communication products, systems, services, and processes. In comparison with the electrical engineering, which deals with the general aspect of design and development of electrical equipment, such as power generators and electric motors, BSECE focuses on the study of design and development of electronic equipment such as semiconductors and transmitters to be used in distant communications. Electronics engineering students may want to become electrical and electronics installer who installs, repairs, or replaces a variety of electrical equipment in telecommunications, transportation, utilities, and other industries. Or they may want to become telecommunications engineer, who designs and oversees the installation of telecommunications equipment or facilities at telecommunication companies like PLDT, Globe, and DITO. They may also want to become biomedical engineer, who is tasked with designing and developing electronic medical equipment. Next would be computer engineering. In a nutshell, the program equips students with the ability to analyze, plan, design, install, operate and maintain digital devices and computer hardware and software systems. These include operating systems such as Windows and Linux, middleware such as Android systems, game engines, business applications such as Microsoft Office, accounting software, and network control systems such as Cisco, and computer games. Computer engineering students may want to become software developer, who designs and maintains software applications such as mobile and desktop applications, conducts systems tests, troubleshoots customer issues, and corrects system defects. Or they may also want to become systems engineer, who designs and implements computer systems, software and networks, ensures that computer systems function efficiently and securely to support an organization's information technology needs. Or they may want to become network systems administrator or manager, who oversees the implementation and administration of computer and telecommunication networks for an organization. Next would be aerospace engineering. In a nutshell, aerospace engineering is largely the design, construction, and maintenance of satellite, aircraft, spacecraft, missiles, and weapon systems. Main focuses can include flight safety, fuel efficiency, operating cost, and environmental impact. Moreover, they develop advanced technologies to be used in space exploration, aviation, and defense systems. Aerospace engineering students may want to pursue spacecraft and aircraft designer, who formulates conceptual designs and systems that suit customer requirements and other environmental regulations. They may also want to become rocket scientists, who analyzes project requests, proposals, and engineering data to determine feasibility, predictability, and cost of aerospace-related products. Or they may want to pursue mission or payload specialist, who coordinates on-board operation and handles special shuttle unique equipment critical to a space mission. Last but not the least, we have robotics engineering. In a nutshell, this discipline discusses motors, microprocessors, mechanics, artificial intelligence, and sensors. It teaches the theory of electrical, pneumatic, and hydraulic control systems as well as real-time programming and the concepts of work envelope. The class also discusses the various use of robotics in different fields such as in aerospace, medical, automotive, and manufacturing industries. Moreover, a robotics engineer is trained to understand, design, develop, manufacture, and maintain intelligent robots and machines that can be used for the common good. Robotics engineering students may want to pursue biosystem engineer, who works for systems or devices that detects the presence of biological and chemical species. Or they may want to become agricultural instrumentation engineer, who creates and designs robots and robotic systems needed in machine and assembly systems in agricultural industries. Or they may want to pursue automation engineers, who works for robot manufacturers and automation systems in processing companies. Other career opportunities may include robotics programmers, system engineer, maintenance engineer, CAD designer, biomedical technology, food technology, aerospace technology, and microelectromechanical technology. Alright, architects and engineers are awesome. Perhaps some of you have not yet decided what you want to study during your college years and consequently may have many questions in mind. And don't be concerned about your chosen profession changing in a way that makes your education obsolete. Most companies assist their engineers in acquiring further training and education to keep up with the changing technologies. A good engineering education will enable you to become a good problem solver throughout your life, regardless of the particular problem or situation. You may wonder during the next few years of school why you need to be learning some of the material you are studying. Sometimes, your homework may seem irrelevant, trivial, or out of date. Rest assured that you are learning both content information and strategies of thinking and analysis that will equip you to face future challenges, ones that do not even exist yet. That's it for the Introduction to Engineering and Architecture courses. See you again for the next video. Goodbye, brilliant minds!